Hello, this is a test of the mMagic controller. This is the test that I use to verify all the controller functions. One thing, if you're going to be doing this to diagnose a controller, make sure that the fuse is good, and the only way to know the fuse is good is not by visual inspection. Put an ohm meter on it. If it measures 0 ohms, it's a good fuse. But because we've had some fuses come back and visually they passed the inspection, but they had actually open circuited. So anyway, what you need for this test is 18 volt power supply. In this case, I've got a Super G Plus on something that resembles a track. The wires here go to the power supply. These wires go to the voltmeter, and the voltmeter is measuring volts that are going to the car. Now, when you get the controller, you want the controls on the controller set like this. You want the TP switch in 0 all the way up, coast brake in off or neutral, range switch in low, coast brake pot turned all the way in this direction, sensitivity all the way in this direction, and the UVL dial all the way in that direction. Now you're ready to go. That's the setup that you want the controller to be in when you start the test. The first test is verifying that the reverse polarity protection is working, and to do that we intentionally wire the controller up backwards. As you can see, it's black, white, red as my connections. I'm hooking white to black, and I'm going to touch black to white. And you should see power supply voltage. All right, that's proven that the reverse power protection is working. Now we can hook up the white wire and the black wire. We're going to leave the red wire disconnected for now. Okay, now we're going to test the controller function itself, and this is essentially the sensitivity test. So you want to just roll the controller up, and you can hear the voltmeter start. You can hear the car start up. And you've got 18.71, that's power supply voltage. And you roll it down. Now I usually stop about right there and then flip the switch in a high range. So now I can check the high range. Okay, so I know the controller's working. Now to check the sensitivity pot, again, I've just barely got the car ticking over at 3 volts. And I roll the sensitivity pot up, and you can see the voltage changing. You can do the same thing at high range. All right, now we'll check coast and brake. The easiest thing to do is to flip it into coast. If you're lucky, the car will start up. Otherwise, you have to give it a little bit of a kick. The trigger's fully released. Now what I'm going to do is just to press it slightly. Okay, I just picked up the micro switch. I let go and I've got the coast. I'm on coast again. Now we roll coast up. And again, we're checking for smooth travel all the way. Now it's time to check brake. To do that, we hook up the red wire. Now, first thing, let's leave the switch off, and you can get an idea how long it takes for the motor to coast down when I release the trigger. Now we'll hit the brake. A little slower, but not a lot, but there's a difference in time. If I go up to 50% brake, a little quicker, we go to 100% brake. And it's almost instantaneous. Now we check the last 2 functions, which is the TPC switch and the UVL dial. TPC controls the relationship between these 2 contacts. Some people call them button to button. In other words, when I'm at full power, I am connected button to button, and I get full power to whatever the power supply is putting out, I get that to the car. So, and the TPC switch controls that. So if we go to full throttle, I'm at power supply voltage. With the switch in the 1 position, I've dropped a little over half a volt, and that's because of a diode right here, that when I go to the down position, that diode is connected to the circuit, and that gives me about a half a volt to 7/10 volt drop. Now when the switch is in the 2nd position, there is no connection between these two at any time. And you can see I've dropped to 17 volts. So the UVL dial now allows me to dial the voltage up and down, and this is the upper voltage limit. So what this works out is, of course, if you're in the 2 position, and this is ideal for gravity cars, you can limit the voltage the controller is going to put out to something the gravity car likes. Most of the CAN motors don't like anything above 12 volts, maybe 13 volts. Well, you can bring the controller down to that. Now, sensitivity does interrelate, because sensitivity increases the bottom, UVL cuts off the top. So if I increase the bottom, the top's going up a little bit. So they do interrelate. Now, what comes in handy with a G-Jet or a T-Jet, especially with slip-on silicones, is to put the TPC switch in either 0 or 1 and just dial a little bit out. On my last track, I had a turn, and this was with both T-Jets and G-Jets, that you could roll up to full throttle in the middle of the turn, but you didn't want to hammer it. So what I did is I backed down to about 15, 16 volts just before full throttle, and what I do is when I enter the corner, I would roll it up right to that point, and when I hit the main straight, I just punch it the last little bit, and it worked beautifully. It was extremely consistent, and it really worked. So that's something to think about. What we found out with G-Jets in long endurance races, for example, especially with silicones, you can start with the switch in 0 for, let's say, 3 to 5 minutes, flip it to 1. And what that does is that allows the tires to stay under the car. In other words, you're not going sideways. You haven't lost your tires yet, for another 3 to 4 minutes. So it does help you prolong the time between pit stops. Obviously, you lose a little bit of speed, but hopefully you make it up because you're not making pit stops. That's the test. This controller has passed its test. It will be going off to its new owner tomorrow, and I hope you enjoyed this. Have any questions? Please give me a call.